Welcome to Accelerated Engineering. My name is John. This is the video encyclopedia entry for the hyperbolic cotangent function, COTH. The hyperbolic cotangent function takes an input argument assumed to be in radians and outputs the hyperbolic cotangent for that function. The hyperbolic cotangent can be defined as the hyperbolic cosine divided by the hyperbolic sine. Looking back at those functions, we can see that the hyperbolic cosine is fairly well defined around 0, but that the hyperbolic sine, well, it crosses the 0 line. It crosses y equals 0 at x equals 0, which means that, as expected, the cotangent hyperbolic function has an asymptote at 0. I've just plotted a few values assumed to be in degrees, because I think in degrees, and then converted to radians and calculated the hyperbolic cotangent. And we can see that this provides an output ranging from not closer to 0 than -1 on the negative side, and not closer to 0 than +1 on the positive side. I hope that was clear. That was hard to say. So for very, very small numbers, the hyperbolic cotangent goes to infinity. If I put in a very, very small number, in fact, it's just going to blow up. Can I expand this? Come on. Oh, it's not even going to behave. It just throws me an error. There we go. Get a general format. That behaves better. There we go. For a very, very small positive number, very, very large positive output. For a very, very small negative number, we get a very, very large negative output. This is for values approaching 0. For very, very large values, this function still handles well because it approaches 1 for very, very large values, both positive and negative. Now, don't input very, very large positive values. This is, again, 1 times 10 to the 308 is absurdly large. Even if we get up to 100, Excel just rounds it off to 1 and -1 at the output for inputs of 100. I think that even for 10, 1 times 10 to the 1 is 10. We've already got that value for rounded to 1 and -1. And for 1 times 10 to the 0.1, which is 1.2 or about 1.3, then we're already starting to get within 20% of numerical value 1. Some related functions to the hyperbolic cotangent would, of course, be the hyperbolic tangent, the inverse of this function, the hyperbolic cosine and hyperbolic sine, which are used to help define this. And you can always go back to the plain old cotangent function, which is defined using circles instead of defined using hyperbolas, and behaves a little bit more nicely and periodically. Anyway, this concludes the video encyclopedia for the hyperbolic cotangent function. Please take a moment to like this video, comment, and subscribe if you want to see more content like this. Thanks for watching.